for our last lesson of Unit 1, we are going to be looking at the law of sines and the law of cosines with some more word problems, and then we will be talking about how to find the area of a triangle. So for the law of sines, we have our sine A over A equals sine B over B equals sine C over C. And as we remember, we only use two pieces of this. So we're only going to use this when we're given two angles and a side. Let me change the size of that a little bit. There we go. So that means that we have a situation of AAS or ASA. And then you can also use it when you have two sides and one angle. And so that leaves you with SSA. So your law of cosines needs to be used when you're given two sides and one angle. So that would be a situation like SAS. Or when you're given three sides, because that way you can find an angle. So let's look at some application problems. So for number 1, we have that Cincinnati, Ohio is 540 miles due east of Kansas City, Missouri. The bearing from Kansas City, Missouri, or Kansas City to Nashville, Tennessee is south 64 degrees east, and the bearing from Cincinnati to Nashville is south 29 degrees west. So first of all, we have Kansas City, and then we have Cincinnati. Those two cities are 540 miles apart. And then we have Nashville, that is south of both of them. So if we think about that north-south line from each of these cities, then Kansas City to Nashville is south 64 degrees east. So we're going to go south and east 64 degrees to Nashville. And then Cincinnati to Nashville is 29 degrees. So south 29 degrees west. So both of these angles are right angles. So that means that they're a total of 90 degrees. So if we subtract 64 from the 90, that's going to leave us 26 degrees inside the triangle. And then if we subtract 29 from 90, that leaves us with 61 degrees. So to get that third angle of the triangle, we would just need to subtract both of these from 180, and that should leave us with 93 degrees. So first we are asked to find the distance from Kansas City to Nashville. So we're going to go ahead and call this X, because that would be this leg right here. And so we could use the law of sines for it, because we have the angle that's opposite, and we have the 540 and the 93 that are opposite of each other. And so the law of sines is usually a little bit shorter than law of cosines. So if we have that set up, it's usually what I go for. So let's go ahead and get it set up. So we have the sine of 93 over 540 equals the sine of 61 over x. So we had x times the sine of 93 equals 540 times the sine of 61. And then we're going to divide by the sine of 93. And so that gives us 472.9 miles. So x is 472.9. And then for part B, we need to find the distance from Cincinnati to Nashville. So I'm going to go ahead and call this y. And so we could probably use the law of sines again because we still have that sine of 93 over 540. And we know all three angles. So we could use the sine of 26 over y and then cross multiply. So we would have y times the sine of 93 equals 540 times the sine of 26. So then when we divide, we should get 237 miles. So let's look at number 2. So for number 2, we have two ships that are leaving the same port. So ship A is going to sail north 45 degrees west. So if we have our port here, then ship A is going north and west. And so it's going out 8 miles. Now, ship B sails 14 miles at a bearing of south 70 degrees west. So ship B is going out here. And so we have a bearing of 45 degrees for ship A. And then ship B is 70 degrees. So we have, so now to the nearest tenth of a mile, how far is ship A from ship B? So we are looking for side AB as our X. So we will go ahead and subtract from 180 to get that angle measure. And so that leaves us with 65 degrees. And we have the 14 for how far ship B sailed. So this looks like a situation where we have SAS in what's given. So that is a situation for the law of cosines. So I'm going to go ahead and fill things in. So we have x squared equals 14 squared plus 8 squared minus 2 times 14 times 8 times the cosine of 65. And so then we have 14 squared, which is 196, plus 8 squared, which is 64. And then 2 times 14 times 8 gives you 224 times the cosine of 65. If we put all of these in, we should get 165.3335. And then we're going to take the square root. So when we do take that square root, we get 12.9 miles. Okay, so now we're going to look at what happens if ship A tries to sail to ship B. What bearing should it take? So this is going to take a lot of use of geometry just so you know, because essentially you are taking ship A and making it its own center of your compass. So we're going to draw those lines with little red dots. So we're going to now assume ship A is the center of bearing. So let's talk about some things that we know. We know that we have a right triangle that exists right here, because north, south, and east and west are perpendicular of each other. So this is a right triangle. And so this is 45 degrees still, that bearing for ship A from the port. And so that leaves 45 degrees inside that little triangle for this angle right here. Okay, which means that we do have 45 degrees on the inside of the triangle between pretty much the purple line and the red dotted line, because this is also a right angle. I hope you can track what all these lines are. So what we will do is we need to figure out what this angle is total. We're going to call this angle A. And so we can now use the law of sines for this. So we are going to take, the sine of A over 14. And it is going to equal the sine of 65 over that 12.9 that we found. So we'll cross multiply, so 12.9 will, times sine A will equal 14 times sine 65. And so we'll divide by 12.9. And so that gives us the sine of A as 0.9836. So yes, it will work. So we'll take the arc sine. And that will give us angle A equals 79.6 degrees. Okay, so this entire angle right here is 79.6. But for our bearing, we only need this little piece that is right here. So what we're going to do is we're going to take that 79.6 and we're going to subtract out the 45 that's on the other side of that axis. And that is going to give us 34.6. So the bearing that ship A needs to take is south 34.6 degrees west. All right, so now let's talk about area. So for the area of our triangles, we learned in geometry that the area of a triangle is A equals 1/2 base times height. And we also know from looking at our figure here that if we need the sine of C, which is this reference angle right here, that is going to be the height of the triangle over side A. Because height is the opposite side from angle C. So therefore, if we go and we solve for H, we'd have to multiply by A. So that would be A times sine C. And so then we could substitute that in for height. So instead we would have 1/2 base times A sine C. And so we're just going to make that a little bit prettier. And so we have 1/2 AB times the sine of C. And so this can be a formula that we use when we're not given the base and height of the triangle. But here is the thing. You do have to have angle C is the included angle between A and B. So side C, so angle C has to be that included angle. Okay. So let's go ahead and use this formula now to find the area of some triangles. So on number 3, we have our two sides as 11 and 16, and then 105 is that included angle, so we can use it. So we have A equals 1/2, and then we're going to have 16 times 11 times the sine of 105. So 1/2 times 16 is 8. 8 times 11 is 88. So we have 88 sine 105. And so 80, that gives us 85 feet squared when we put that in the calculator. And there we go. So on number 4, with what we're given right now, it's actually impossible to use this formula to find the area of the triangle, but we can do some subtraction. So I have 180 minus, and then 126 plus 22. And so that gives us 32 degrees as that one missing angle. So then we can go ahead and set up a ratio to find this missing side right here, and then we'll have an included angle. So we can have, let's see, the sine of 32 over 13 equals the sine of 22 over x, cross multiply, x times the sine of 32 equals 13 sine 32, or 22, sorry, a lot of 2's, and then we're going to divide by sine 32. So we're going to put this in the calculator, and that should give us 9.2. So x equals 9.2. So now we can use that. And our area formula, so we'll have 1/2 times 9.2 times 13. And then 126 is that included angle, so the sine of 126. And we just need to put that in our calculator to get our area. So let's see, if we simplify a little bit beforehand, you get like 59.8 times the sine of 126. And that gives us 48.4 kilometers squared. All right, so then number 5, we need an angle. So we need to pick which angle. I'm going to go ahead and go for this one. So I'm going to call that X. And so then we are going to have to set up the law of cosines, because we need 2 angles to do law of sines, which we don't have. So we will have 16 as the opposite side. So we'll have 16 squared equals 6 squared plus 14 squared minus 2 times 6 times 14 times cosine x. Then 16 squared is 256 equals 36 plus 196 minus, let's see, 2 times 6 is 12 times 14 is 168 cosine x. 256 equals, let's see, add those together, you get 232 minus 168 cosine x. And subtract your 232, that leaves you with 24 equals negative 168 cosine x. And we'll divide by that negative 168. And so when we divide, we get a negative 0.1429, and then undo that cosine. So x should give you 98.2 degrees. So then we will go ahead and find the area. Luckily, that is the short part. So we'll have 1/2 times 6 times 14. And then our included angle is the sine of 98.2. So half of 6 is 3. 3 times 14 is 42. So you have 42 times the sine of 98.2. And that gives us 41.6 yards squared. All right, so let's look at one more way to find area, and then we will call it a day. So that is Heron's formula. So Heron's formula does look a little bit weird because we do have A equals the square root of S times S minus A, S minus B, and S minus C. And that is where S stands for semi-perimeter. And so your semi-perimeter is where you take half of your perimeter. So you're going to add together sides A, B, and C, and then multiply it by 1/2 or divide by 2. And so your S becomes what you plug in to these 4 places, and then in those parentheses you are actually subtracting the length of your sides. So it's just another workaround when you're given 3 sides if you really don't feel like using the law of cosines. So now we are going to use Heron's formula on number 6. So the first thing we have to do is find that semi-perimeter. So S is going to equal 1/2 of 18 plus 21 plus 19. So that gives us 1/2 of 58, which is 29. So that's what we will use for S. And then underneath that radical, we'll have A equals the square root. Make a big long one. We got a lot to put under there. We have 29 for that semi-perimeter. And then 29 minus 18. I usually just go around the triangle. So 29 minus 19. And then 29 minus 21. So we're going to go ahead and subtract. So we have 29 times 11. And then 29 minus 19 is 10. 29 minus 21 is 8. And then we'll multiply all these together. So that gets us 25,520. And then we need to take the square root of this. So this is why we have calculators. So we have that square root as 159.7 when we round, and that is square miles. There we go. So on number 7, we have a triangular shaped piece of glass, has side lengths that measure 35 inches, 27 inches, and 14 inches. So we need to find the area of the glass to the nearest tenth of a square inch. So if you notice, we are just given side lengths here. We're not given anything as a height. We don't even know what kind of triangle it is. So since we do have those 3 side lengths, the easiest way to go is going to be Heron's formula. So we need to find that semi-perimeter first. So that gives us 1/2 times 35 plus 27 plus 14. And then we have 1/2 times 76. And that equals 38. And so then we have our area. So we'll have a big square root. So we have 38 because that's our semi-perimeter. We have 38 minus 35. And then 38 minus 27. And I didn't make it long enough. 38 minus 14. So then we'll do our subtraction. So we have 38 times 3. 38 times 11. And then 38 minus 14 is 24. So when we multiply all of those underneath that radical together, we get 30,096. We'll take the square root, and that gets us 173.5 square inches.